Now this video brings you a video explanation of the Pulsar Hackathon entry. Our entry is to introduce APM systems such as SkyWalking into Pulsar Broker. The following is the catalog of this video explanation. First, why do you need sample tracking? The second, how is the sampling tracking implemented in Pulsar Broker? The third is our visual display results, and the fourth is how to do sampling tracking based on time delay. The fifth is some of our prospects after this project. Why do you need sample tracking? Now Pulsar Broker has two methods to locate the problem, log output and metric output. However, the sampling and tracking link is missing. For logs, Elasticsearch is used to connect metric indicators by the Prometheus Beyond display. The sampling tracking is missing, so we introduced SkyWalking for sampling tracking. How is sampling tracking implemented in Pulsar Broker? The following will be explained based on these 3 points. The first is the basic principle of sampling and tracking, and the second is the sampling and tracking method of a single message. The sampling and tracking principle of the third batch of messages. The basic principle of sampling tracking. As shown in the figure below, we can see when a message flows through various microservices. For example, from the user node to A to C to E, this message will carry trace ID, sampling and tracking data, and the processing time of the node. After sending these data to SkyWalking, SkyWalking will perform calculations on them, and then get the time consuming of each stage, and make some alarms. The sampling and tracking of a single message is realized. When a message is delivered from the source system, it will carry trace ID and other data required by the sampling and tracking system. When it is sent to the producer, the data is stored in the property. In order to send these data to the Pulsar Broker, we will add a message header field to the command send. Put the sampled and tracked data in the property into the message head to send to the Pulsar Broker. After being sent to the broker, it will be written to the broker metadata. When sent from the Pulsar Broker to the consumer, a message header field will be added to the command message, and sampling trace data will be read from the broker metadata and written to the command message to be sent to the consumer. The consumer updates the sampled and tracked data from the message head to the property. In produce, Pulsar Broker and consumer are to SkyWalking send the sample trace data, or printing log. Batch message sampling and tracking. The data flow method of batch message sampling and tracking is the same as that of a single message. The difference is that multiple messages are sent in batches when the producer sends a message to the Pulsar Broker. Then we need to want to have been sampled message property integrated together as a whole batch message head is sent to the Pulsar Broker and Pulsar Broker to the consumer when the message is sent. The message header of the message subdivision solution to each message property. Such a consumer to get a single message property data sample trace has been updated. Visualization of the results. We track the use of SkyWalking and Elasticsearch, two systems for display, and summarize these two visualization systems. As shown below, in SkyWalking the dashboard, we can see a delay message display page. Then SkyWalking topology map, as we can see from Fig producer to Pulsar Broker, then consumer data transfer process. The following figure is the message tracking page of SkyWalking sampling and tracking. We can query the time consumption of this message in the producer, in the Pulsar Broker, and in each stage of the Pulsar Broker to the consumer according to the trace ID. In addition to SkyWalking, we also track the time delay. For messages with a large time delay, we will print logs. The following is a summary of visualization. The first is the sampling method. Both Elasticsearch and SkyWalking use the SkyWalking plugin to generate sampling data. The second is the output format. Elasticsearch is to collect logs printed by Pulsar, and SkyWalking is to send trace data to Kafka by the Pulsar Broker. The third is the transmission method of trace data. Both Elasticsearch and SkyWalking are transmitted through command send broker metadata and command message. Sampling tracking based on time delay is currently mainly implemented through log output. We carry the time information of the previous node on each node. Here, we can calculate the time difference between each node, If the time difference is greater than our threshold, then print the log. Looking to the future, the next we will be sample track in Bookkeeper and implementation. And we hope to sample tracing on delayed messages, to effectively find the out-of-date delayed message and alarms. The following is a demonstration of the results of our work for everyone. First of all, the interface shows the results of sampling and tracking based on time delay. We can see it in EastExerCH. When the time delay of a message is too large, the log will be printed. These excessively delayed messages can be queried in Kibana. Then we check on SkyWalking based on the traceset of this message. First, what we see is the dashboard interface. Here is the topology map page to see him. The data flow is from producer to broker to consumer. Then we query the message just now. Here you can see the flow of this message. Here is from the producer to the broker, and then from the broker to the consumer. The following figure shows the start time of this message at each stage and the corresponding processing time in each stage.